Determine the radius of convergence of the power series summation n going from 1 to infinity of 3 over 5 to the n times x minus 4 to the n using the ratio test. So let's start this thing off right here. For the ratio test, we need a formula for the nth term. Well, that's going to be 3 times x minus 4 to the nth power over 5 to the n. I'm writing it as a fraction because I know I'm going to want to flip it later on. That means the n plus first term is going to be 3 times x minus 4 to the n plus 1 over 5 to the n plus 1. Remember, we're replacing the n's by n plus 1, not the x's. Next, the ratio of the consecutive terms is going to be the a n plus 1 term, 3 times x minus 4 to the n plus 1, over 5 to the n plus 1. And then we'll multiply by the reciprocal of the nth term, so that would be 5 to the n over 3 times x minus 4 to the n. And then we'll get cancellations here and there. The 3's cancel. The 5 to the n's will cancel. 5 to the n will go into the denominator with 5 left over. And then these terms will cancel, leaving us with a single x minus 4 in the numerator. And so there's our ratio of consecutive terms, x minus 4 over 5. Now let's take the limit as n tends to infinity of this particular expression. So that's the limit as n tends to infinity of x minus 4 over 5. Now notice that there's no n's anywhere in this formula at all, so it's just a constant. So the limiting value is x minus 4 over 5. Now the ratio test says we need to take the absolute value of this and determine when that's less than 1. So let's solve that inequality. That's the same thing as saying that x minus 4 divided by 5 is between 1 and minus 1. If we multiply everything through by 5, we're going to have x minus 4 is less than, negative 5 and a positive 5. And then if we add 4 to all of the pieces, we'll have minus 1 is less than x is less than 9. And so that means this series converges precisely when x is between minus 1 and 9. Notice that the value directly in between on this interval would be exactly 4, which makes sense, it's the center. And we're getting, there it is, the center. And we're also getting exactly 5 units from the center to either side. And so that would be our radius value. It's also exactly that number right there. So our radius of convergence for this series is exactly 5 units.